Okay, folks, here's part two of this screencast. It ended a little bit sooner than I wanted to last time, but what we're going to do is go through some examples. And we're going to start with our examples that we're going to start with. We're going to look at graphs first, so just graphs. So here we go. We've got a pool being drained. And on the x-axis, we've got time in minutes. So at 0 minutes, that's a time at which the pump was turned on to drain it, or the drain was opened and water started flowing out. At that moment, there were exactly 200 centimeters of water in the pool. So you notice that over time, as time increases, we're going down this curve. At 4 hours, that pool is totally empty. Okay, so starts at 0 and at 4. Now, the question is, can you take more water out after it's empty? I don't think so. So it looks to me like it ends at 0 meters in 4 hours. It started getting drained at 200 meters because that's the depth. And what's the whole idea here is you don't have negative times, right? You just have positive times. So it looks to me like the pool is being drained between 0 and 4 hours because you didn't start draining it at -2 hours. You started draining it at 0 hours. And you can count hours. And then let's see, make that a 0 there. Longest it goes for is 4 hours, because at 4 hours you have to turn the pump off because all the water has been removed. And then that's the domain, and it's a t value because it's on the x-axis, right? There's your domain. And it goes, well, actually just from between here and here. And then the range goes right here. It's on the y-axis. What's the lowest you're allowed to have for y from a real-life perspective? Well, 0 centimeters of water. You can't have negative centimeters of water in your pool. And since the pool overflows at 200, you're never going to have it deeper than 200. So again, the lowest is 0 centimeters. The highest is 200. And what about a football being kicked through again? So you may want to pause and look at that. With the idea that domain the arrow means domain is measured by time, and time is equal to 0 to 4. Well, because what that means is it can include 0 hours, it can include 4 hours. The height or depth of water can be as low as 0 centimeters and as high as 200. Okay, number 2, graph. A football is kicked through the air in a punt. Describe possible domain and range. So here we go. We've got a graph. And this graph tells us that the kicker's foot is 1 meter in the air when he or she kicks it. The ball goes up in the air, reaches a maximum point, and then it comes down. And it would depend whether that ball was caught by someone or does it hit the ground, right? If it was caught by someone, it might get caught at a height of 1 meter. And that would be an interesting scenario because your range then would only go from 1 meter to 10 meters, right? But if we assume that it hits the ground instead of being caught, then we've got this pattern. So it's kicked at a height of 1 meter, goes up and hits a max, which is at 10 meters in the air. Then it comes down and it hits the ground at 4 seconds. And that's our path. So domain, again, is what's on the x-axis. So I'll maybe mark that on. So there's your domain. What x values are allowed? Well, I think the lowest we can go is 0 seconds. The highest we can go right now is 4 seconds. That's how long that punt will stay in the air for. So it hits the ground at 4. That's why the domain ends at 4. Now the range, it represents the height of the ball in meters. So what's the lowest and what's the highest? Well, clearly, in this case, the lowest the ball ever gets is it does hit the ground. So that's meters. So it goes from 0 meters, but the highest it goes is 10 meters. And that's at the peak of its, when the ball is thrown up in the air. And so if you look at this, that represents your range from 0 to 10. and your domain is from 0 to 4 seconds. So let's go on now and do some algebra. Okay, so here's a traditional one from grade 9. We're going to do domain and range, but with equations. So C of n is 12n plus 400. This is like when you rent a bank or you rent a hall. So for example, when my wife and I got married, we rented a hall and we paid a certain amount, a fixed amount or a constant amount for the hall. And then we had to pay for the caterers to pay for the food. And so the hall, and I can't even remember what our hall was, something like $300, or maybe it was more, maybe it was $700. I don't really remember, but I know that they told us the hall was going to be $700 no matter what, whether we had 100 people there or 200 people. And then they would charge us a rate per person for the meal. So there's your equation. It's a linear equation. Starts at 400 and the slope is 12 over 1. So in this case, your y values are always your range, right? So that means cost is the y value. So that's your range. And that means your domain is a number of people, which is a number of meals. So if the hall holds 150 people, what are the domain and range? So it looks like if the hall holds a maximum of 150 people, well, if we looked at our graph, the cost starts at a certain amount here, which is 400 for the hall. That's 0, and we know that the least number of people that can go is 0. You're not going to have negative people, and the hall only holds 150. So what we've got to do is figure out the cost for 150. The domain's pretty clear. The minimum number of people you can have is 0. The most people you can have is 150. Okay, what about the range? The range is a little bit more interesting. As we said, 150 people. So I know the lowest cost I'm going to have is $400, right? I can't have less than 400 because I've got to pay for that hall. So let's take a look at this. So if the hall's rented and no one shows up to my wedding, not even my wife, and then I decide to head home, then that means n equals 0 and 0 people go. So I replace the n here with this 0. So it's $12 per meal times by 0 meals. So that's gone. And then I add on the constant of $400 for the hall, $400. So that's the lowest range value. What about the greatest range value? Well, that occurs when there's 150 people. So I go up to my curve and I go across and figure out the cost. How do I do that with math? I substitute in, right? So I substitute in. So C equals 12 times by 150 plus 400. Okay, 12 times 150. So what is that, right? That 12 times 150 is, what is 12 times 150? 12 times 100 is 1200. Then 12 times the extra 50 would be 600. That's 1800. And then I have the extra 400, so it's 2200. Okay, so I can have from 0 people to 150 people. My cost, if 0 people go, I still pay $400 for the hall. If 150 people go, my total cost is $1,800 plus the $400 for the hall, which is $2,200. Okay, and that, folks, is your domain and range. Your domain is n, the number of meals or number of people that go. Your range is cost. And again, you might want to pause that, rewind it, go through it. So here's another one. This is just an object. This is a projectile motion, right? And it says the equation is negative 4.9 t squared plus 19.6 t plus 58.8. Oh, by the way, we call it S of t. For some reason in math and